Hello learners, today we'll be discussing about greenhouse gases emissions. We know that human actions and activities, particularly the economic activities, since industrial revolution has caused a lot of harm to the environment, particularly the atmospheric environment, wherein you can see for ourselves that the greenhouse gases concentration in the atmosphere has increased tremendously since the industrial revolution. And this increase in greenhouse gas emission has caused an increase in the surface air temperature to the tune of 1 degree centigrade. It is a huge amount, 1 degree centigrade increase in surface air temperature, because that is having a lot of drastic impact on every aspect of the climate system. And when you see, if this global warming, if it continues, if you are not taking any steps for mitigation, then it may lead to catastrophe. In fact, the temperature increase can go up to 1.5 degrees centigrade even between 2030 and 2052. So it's definitely a cause of concern. And in this regard, if you see, the main reason for increase in carbon dioxide concentration, or for that matter any greenhouse gases in the atmosphere, is because of human action, because of the anthropogenic activities and related phenomena like urbanization and changing land use pattern and so on and so forth. When today's session we'll be talking about the greenhouse gases emission, the trend of it, what is the reason for the increase in greenhouse gas concentration, and so on and so forth. So when you look at the concentration, the trend of greenhouse gases concentration, before industrial revolution, the concentration of greenhouse gases, particularly the carbon dioxide, nitrous oxide, methane, it was very less, and that is the reason why there was a stable environment all along. Nevertheless, since industrial revolution, the gases concentration, particularly the greenhouse gases concentration, has increased. And when you talk about the greenhouse gases concentration, I mean these are the radiatively active gases, and our environment is livable, human existence is possible because of these greenhouse gases. It is having a positive impact as well. When I say positive impact, these radiatively active gases has the capacity to absorb the radiation. If the wavelength is more than 4 micrometer, it is having the capability to absorb the long wave radiation. And because of this reason, a famous effect called greenhouse effect is possible. And because of the greenhouse effect, it has contributed to an what you call a 34 degrees centigrade increase in temperatures because of greenhouse gases, and that effect is called as greenhouse effect. And because of the greenhouse effect only, the human beings can exist. In other words, the earth environment is livable, because the average surface air temperature of earth is 15 degrees centigrade, and this 15 degrees centigrade is because of greenhouse effect. Nevertheless, the concentration is increasing, and that is causing a lot of impacts on the different components of the climate system. And when you look at the concentration of greenhouse gases, particularly the carbon dioxide concentration, before the industrial revolution, the concentration was almost stable. It was hovering around 280 parts per million. But now the concentration is drastically increased, and it is going to touch, and it is going to cross even 410 parts per million. So the concentration, you can see for yourself that concentration of 40% increase since the industrial revolution, and that increase is tremendous. When I say it's tremendous, it's basically because of the human action, because many of the activities, whether it is the use of fossil fuels, energy use, or industrial activity, everything is because that lead to increase in the carbon dioxide concentration. So the second important gas is that methane. When you talk about the methane, again the concentration of methane, it has increased, 150% it has increased, the methane concentration. And when you look at the concentration of methane before industrial revolution is very meager, it was around 700 parts per billion, and now it has crossed so much. So that is in fact, and then again when you talk about a methane gas, its main action is because of the land use changes. We'll see one by one what are the reasons for it later. But when you look at the trend, the 150% increase in the concentration of methane, and that is again a cause of concern because the global warming potential of methane is around 24 times more than the carbon dioxide. So the next important gas as far as the trend is concerned, the nitrous oxide again is a very important gas. The concentration of nitrous oxide has increased since industrial revolution about around 20%. So this nitrous oxide is again an important gas when you look at the global warming potential. So so these three are important gases. Let us see one by one the what you call how it is the causes of what you call the source of emission, and thereafter we'll look at the mitigation aspect as well. Now we have seen the trend of greenhouse gases concentration since industrial revolution. Particularly we have seen the trend of carbon dioxide, nitrous oxide and methane. And now we'll see one by one the gases, the concentration, the source of emission, and the ways to reduce the emission or mitigate the emission. When you look at the holistic level, the important activities, economic activities are responsible for increasing the greenhouse gases emission into the atmosphere are basically the energy sector, industrial sector, agriculture and related sectors, building sector, cement production. These are the normal economic activities that are responsible for causing a lot of emissions, greenhouse gas emissions into the atmosphere. The foremost important sector is the energy sector, which is almost responsible for it causes around 35% increase in the greenhouse gases concentration is because of the energy sector. The next important sector is the agriculture, forestry and other land use sector. This sector alone contributes around 24% of greenhouse gases emission into the atmosphere. Next comes your industrial sector, and thereafter the transport and building sector. So the purpose of stating the sectors, the purpose of stating the economic activity responsible for increasing greenhouse gases emissions into the atmosphere are, we can focus on the mitigation strategies. We can focus on these sectors to implement certain strategies so that the greenhouse gases emissions can be reduced, and that is indeed the purpose of all the international agreements on climate change, and it should be a very much part of any climate policy of any government for that matter. So these are the sectors. Now let us look at the gases. The foremost important gases is the carbon dioxide. When you look at the carbon dioxide gas, the precise measurement of carbon dioxide gas, the emissions, the atmospheric concentration, the measurement started way back in 1957 in South Pole, and the consecutive in 1958 in Mauna Loa, the concentration, the instrumental measurement of carbon dioxide started in 1958. Then the concentration of carbon dioxide was very, very less, and when you look at the per annum increase, it is very, very less. It's one parts per million per year. That is an annual increase. But thereafter, if you look at it, because of the population pressure, we are now touching 7.2 billion, and by 2050 the human population will cross 10 billion. So the population pressure and economic activity, industrial activity, urbanization, these all have contributed to increase in the carbon dioxide concentration. That is the reason why, if you look at it now, the present day, it is in 410 parts per million. So slowly and steadily the concentration of the carbon dioxide is increasing. Now per annum, if you look at it, the per annum increase of carbon dioxide is around 2 parts per million. So it is definitely a cause of concern, because we need to take a lot of measures, because every year the concentration is increasing by at the rate of 2 parts per million. So definitely we need to take the measures possible, because we need to look at the sectors responsible for emitting the carbon dioxide, and also we need to look at the possible measures to have more of sink capacity. How to sequester the carbon from the atmosphere. That is the important thing we need to take into account. Another important thing when you look at the carbon cycle, the carbon emission, and definitely the global level cycle. If you look at it, in the atmosphere, whatever the emissions, it is a carbon dioxide emission. It stays in the atmosphere, and half of the percentage whatever we are emitting, it stays in the atmosphere. So remaining half, it is sequestered, whether it is in the vegetation or in the form of biomass or in the oceans. It's a ocean is a huge body, huge body. It also sequesters the carbon dioxide in the form of carbonates, bicarbonates. And when you look at the concentration level, atmosphere is having around 800 gigatons of carbon. As far as the vegetation is concerned, which is sequestering the carbon dioxide from the atmosphere, it is having around 610 gigatons of carbon. And ocean, I said, it is a huge body, a huge body. It is having a lot of carbon dioxide in the form of carbonate and bicarbonate, and it is around 39,000 gigatons of carbon is there in the ocean. When you look at the reasons, the causes of, or in other words, the sources of emission, carbon dioxide, the major sources is use of for fossil fuels, the combustion activity, and the second one is the cement production. And in fact, this both the fossil fuel use and cement production are responsible for releasing to a tune of 70% of carbon dioxide emission into the atmosphere or due to the combustion activity and cement production. And 30% is because of the land use activity. Land use means it can be an agricultural activity, it can be other later land use changes. So that is also responsible for releasing carbon dioxide into the atmosphere. There's only around 30%. So 70% is the combustion activities because of use of fossil fuels. The point to be noted is that we need to switch over from use of fossil fuels to other renewable energy sectors. So in that way, the carbon dioxide emission into the atmosphere can be controlled. That is a significant point to be noted at this juncture. So when you look at so definitely the atmosphere, every year it is gaining more and more of carbon dioxide, and that is responsible for increasing surface air temperature. That's the point I wanted to stress here. So when you look at the carbon dioxide as a greenhouse gases, this particular gas, carbon dioxide, absorbs long wave radiation. I said it's all greenhouse gases or radiatively active gases absorb the long wave radiation more than 4 micrometer. And as far as the absorption band of carbon dioxide is concerned, it absorbs at 2.7 micrometer, 4.3 micrometer and 15 micrometer. So these are the absorption bands for carbon dioxide. Okay, and when you look at the other gas, that is methane, as I told you that the concentration of methane since industrial revolution has random jump. It's a wide jump. In fact, 150% increases there, 750 parts per billion to 1800 parts per billion. It's so huge, and the main reason is the agricultural activity, the rice production and livestock activity. Basically, the methane emission is because of microorganism induced activities. Basically, that is the reason why, because the methane is emitted into the atmosphere, whether it's a paddy cultivation or a livestock. Because in the case of livestock, the ruminants, particularly the ruminants, that releases a lot of methane into the atmosphere. These are the two important reasons, rice production and livestock. In fact, 115 teragram of the methane is released because of these two activities, the paddy production and livestock. So the stress should be on this paddy production and how to reduce the methane emission from the livestock. Then the third important source as far as methane is concerned, it is the waste management. Anaerobic decomposition also releases methane. So the waste management strategy, particularly the landfills, they also releases methane into the atmosphere. So our focus should be on these three important sectors: the agricultural sector and the waste management sector, if you wanted to reduce the methane emission. Okay. As far as the greenhouse gas is concerned, methane, yes, it is having an absorption band at 7.7 micrometer. But very important point as far as methane is concerned, it's having a very short residence time in the atmosphere. It's between 9 to 15 years. It's very short residence time. But it is it can be removed from the atmospheric system by reacting with an hydroxyl group. think the methane is reacting with the hydroxyl group. If the concentration of hydroxyl group in the atmosphere, if it decreases, what will happen? The residence time will increase. So the concentration of hydroxyl group is very, very important thing. So when methane reacts with an hydroxyl group, it releases water vapor, it releases carbon dioxide and ozone. Again, that is a cause of concern. Why? Because water vapor is a product of this particular reaction. Water vapor is again greenhouse gases. So again, it should be taken into account, that particular point. And third important point as far as the reaction of methane with the hydroxyl group is, the product is ozone. Ozone is again a greenhouse gases. So this reaction, the methane reaction with hydroxyl group, has to be taken into account because it's having a multiple kind of effect, because the water vapor, the ozone is also released into the atmosphere as a byproduct of the particular reaction. And as far as the methane, the concentration in the atmosphere is concerned, a huge stock of methane is there lying deep inside the permafrost region. So there is a possibility of positive feedback. When I say possibility, because of increase in surface air temperature, the permafrost can melt, and because of melting of permafrost region, the methane lying deep inside, it can come out of the system, and that can further the concentration of methane to the atmosphere, and that can lead to a positive feedback. When I say positive feedback, the surface air temperature will further increase. So that is about the methane, the greenhouse gas. Next important gas is the nitrous oxide. When I talk about nitrous oxide, the concentration of nitrous oxide has increased from 275 parts per billion to 320 parts per billion. The increase is around 20%. When you look at the concentration of nitrous oxide, like your methane gas, the main reason is the agriculture related activities, because the nitrification action, that's basically the microbial mediated process. Nitrification is a process that releases the nitrous oxide into the atmosphere. So what are the reasons, what are the sources of it? Forest clearing activity and use of nitrogenous fertilizers like urea and any kind of synthetic fertilizers we are applying to the agriculture field, that also releases nitrous oxide into the atmosphere, and a very meager amount. Even the combustion activity also responsible for nitrous oxide emission into the atmosphere. So these are the sources. And as far as the degradation of nitrous oxide is concerned, it degrades only in the stratosphere region by an activity called photolysis. That is about the degradation of nitrous oxide. And the absorption band for nitrous oxide is at around 7.8 micrometer and 8.6 micrometer. So these are the three important gases. So what is the significance of these particular gases? The source of emissions, when you look at it, is that when you wanted to contain the emission of carbon dioxide, methane and nitrous oxide, our focus should be on the sectors responsible. So for instance, if you wanted to contain the carbon dioxide concentration into the atmosphere, how you will be doing it? So the focus should be on the energy sector. You'll be trying to switch over from the fossil fuel sector to the renewable energy sector. In that way, the emission of carbon dioxide can be controlled. The second important thing is that trying to increase the resource efficiency. So the second aspect is that resource use efficiency. So whatever the activities, industrial activity we are doing it, we'll try to increase the efficiency. When you increase the efficiency, so that can drastically reduce the emission of carbon dioxide into the atmosphere. The third important aspect as far as the carbon dioxide is concerned, so we need to have the consumption pattern, sustainable consumption, that also can reduce the carbon dioxide emission into the atmosphere. These are the basic things at this juncture we can state. Later on we can discuss about various mitigation strategies pertaining to different gases. And as far as the non-carbon dioxide greenhouse gases is concerned, like methane and nitrous oxide, as I told you, the important activity responsible for these non-carbon dioxide gases are basically land use changes, basically agricultural activity. So agricultural activity, how you can make it, how can you transform the agricultural activity so that the greenhouse gases, particularly the methane and the nitrous oxide emission, can be reduced. So there is a kind of a transformation, agriculture transformation is required. When I talk about agriculture transformation, I mean to say that whatever the industrial intensive and industrial agricultural activity we are doing it, we'll try to focus on those aspects in a way that the emissions of methane and nitrous oxide can be reduced. So you'll try to switch over from using the synthetic fertilizers to more of organic manures and a kind of a transformation in agricultural activity. Think about a strategy called climate smart agriculture. So in that way, when you switch over to climate smart agriculture strategies, so animal husbandry activity or agricultural activity, everything will be having a focus on three important aspects. One is the reduction in greenhouse gases from agricultural activity. The second important thing is that we'll try to adapt the agricultural system to changing climate. So that is the second important objective of climate smart agriculture. Third important thing is that whatever agricultural activity, the main focus is we need to achieve food security. So the climate smart agriculture, because it's having itself inbuilt, the transformation, agriculture transformation within it. So definitely that can help us to reduce the methane and nitrous oxide emission from agricultural activity. So this is in nutshell about the ways to minimize the emission, methane and nitrous oxide. So in today's session, we have discussed about the greenhouse gases emission. We have just focused on three important gases, particularly the carbon dioxide, methane and nitrous oxide. And I have stated in a very comprehensive manner what are the mitigation strategies. In coming sessions, we'll be talking about the various mitigation strategies and adaptation strategies also sector-wise. So that's it for today's session. Thank you.